Welcome. I'm Bill Wake. This is my weekly summary of the work I've done on Twitch, and lately we've started a new project I'm calling Fiume. Its goal is to track scenarios of financial pools and streams over time. So I'm thinking of it as something to help me think about when should I formally retire or take Social Security, or what happens if this. So we'll see what comes of it. And on the technical side, I'm hoping to use observable and Swift data, which I've never used Swift data other than maybe a toy app. So the metaphor I have is streams and pools. And the idea is this is money. Sometimes it's a stream. It's money flowing in or out, like a salary or annuity or a loan payment. Or it's a pool of money. It's just money sitting somewhere, savings, IRAs, things like that. They may grow, but mostly they're just sitting there. All right. And so this past week, we started with the idea of a list of streams. I think adding the pools will be relatively easy once we understand how that all works. Then we spiked a tree representation. Would it be better to represent it as an enum, a struct, or a class? And we ended up doing a class. And then we evolved from the list of streams to the tree of streams and added this idea of alternative scenarios and developed a basic UI that's got a tree view and a chart. So here's my kind of general idea. I'm imagining those blocks on the left. So like kind of working bottom to top, although I'm not quite sure which way to put the direction. But the baseline box there, these are things that are just kind of like given facts about the situation. So Alice was born in 70 and Bob in 80, and they have this much in here, and here's their salary. And then the second section, the plan, my idea there is that these are things that they've decided how they're going to manage their finances. And so every month looks like they have a $700 excess. They're going to put at least $400 into some sort of savings. And then we want to look at three scenarios. I think this is for Alice retiring. Should she retire at 62, 67, or 70? You get different amounts of Social Security depending on the age you retire at. So I want something where I can kind of accumulate ideas or plans or changes and see the net result. So if where I have stopped salary in 2030, before I just had a salary that was going arbitrarily long. Now I'm kind of adding a constraint on top of it. And then the output, I think at least a graph of net worth, maybe a monthly flow might be interesting. How much are you coming out ahead or behind? But I'm not quite sure where that is. And then the scenarios, I think I'm going to be able to kind of stack the graphs and then maybe do some things to help you look at them dynamically. So for this application, I didn't come in with a fixed model in mind, how do you implement this? So I've explored several things, and I think the core, these three models are at least part of what's going on. So one is there's the notion of an and or tree, and basically it says you have a tree like normal, but the default is saying this or this happens. I guess the no arc between the legs. All right, so that's the or part. So if you look at node Q, you got T or U are underneath node Q. But underneath node P, you have Q and R there. So that's an and arc. And these things, I mean, they get used for like game trees for analyzing games, I guess. Maybe some logical proposition kind of working your way through the consequences, prologue sort of thing. But for us, I'm going to mostly have ands. Most of those lines in the previous page were ands until you get to the scenarios, and those are the ors. Now, I could stack up multiple scenarios, multiple blocks of scenarios. Alice retires at 62, but Bob waits till he's 67, and so on. And then I would have the notion of combinations. So that's the middle one there. If you have 4 possibilities for something and 3 possibilities for something else, you have 12 possible combinations for pairs of those things. And same thing, if I have, 62, 67, or 70 for both Bob and Alice, then I have 9 scenarios that I would want to look at. Now this grows fast. I mean, basically every set of choices multiplies by what you have already. So I don't know that you can handle, I mean, you could easily define a million scenarios, but I'm not sure we can graph it or show it or work with it very well. So there's some limitations to this, but I think we could comfortably do, um, well, if we had 4 stacks of 3 choices, that's 81 combinations. Um, 6 stacks of 2 is 2 to the 6 is 64, right? So there's some reasonable-ish numbers. I can imagine doing 100 graphs. They're just not that big. All right, and then the third model I actually learned this years ago. The first source code control system I used worked like this, but the idea, it's panes of glass, and you're going to stack these panes, and some parts of them are transparent, and some parts of them are opaque. And so if I put yellow on the bottom, then red, then blue, the net is the picture on the right with the 3 colors in it. And what you're seeing through, like you're seeing through the blue level to see the red, and you're seeing through the red level, the transparent part, to see the yellow. And this is the idea that later information overrides earlier information. The source control I mentioned, it would have sort of a master source at one level, and then another source tree at another level, and then the individual source tree on your desk, and it would search through the source tree to find each file. And if you created a duplicate or changed a file, you had a local copy that got seen first. So and they're somewhat like that now, I guess. All right. So anyway, we've worked this week mostly on the and or tree. Seeing that is kind of the goal so far. All right. So let's go take a look at the source, and then we'll run a quick demo and call it a wrap. All right. So let's start with the plan, or the plan tree. So this is that and or tree that I talked about. And we're using a composite approach, like design pattern composite. There's a parent node that defines the behavior of both leaves and interior nodes. So every node we have has a name, and then children and append are kind of tree manipulation. They don't make sense for a child, a leaf node, but they do make sense for the other node. And putting them up in the protocol lets us kind of treat them more the same. It's a bit of a trade-off. And then finally, there's a net that says, for this month, how much money do I have? Okay, so if my stream says I get $2,000 a month, great, I'll have $2,000 net from that. And if I've got an and tree, which is, I get a salary of $2,000 and my spouse's salary is $2,500, then this total salary for this node is $4,500. All right, the second one is the leaf class. And this thing basically it's built around streams. When we get to pools and other things, we may need different kinds of leaves, or we may have to make this more generic, but we'll get there. All right, so you're going to own a stream, and you have a name, which is the stream's name, and you have children. Well, you don't, because you're a leaf, so you answer nil for that. And then the net is going to be whatever the stream's amount is. And finally, append gets ignored. I probably should put some sort of die instruction there. Shouldn't happen. So far, we haven't taken into account which month it is. So we're just saying whatever your amount is, we'll take it. Okay, you'll see the consequences of that. And then finally, we have the composite part, which is, this is the node that contains children. Let me skip over the first little bit there, but you can see we have a name. We also have a combining operator, because we have both and trees and or trees represented here. How do you treat the net of an and? Well, you sum it. How do you treat the net of an or? Well, that's a little more complicated. For now, we've said we'll take the max, but we can pass that operator in. All right, we can track the children, and then our constructor, we take the name and the combining operator. All right, so append is sort of a standard tree operation. If I don't have any children, I'll create, and I'm given one, I'll create that one there. Otherwise, I'll append. So I'm just adding children. And then finally, my net. If I don't have any children, if it's nil, then I return money 0. Otherwise, I use my operator and a reduce. So reduce says put the operator between every element of the list and do it. So if you do 2,500 plus 2,000 plus 1,000, whatever, you're basically adding those up. If it's the max, well, it's the result so far max the next item, and it works its way through taking those and finding the max. All right, there's room for improvement on this, but it's getting the tree structure in place is the big thing. All right, now I started to come back to these. So my and trees and my or trees, they're really the only difference is the operator. So or is using max and is using plus. We could also think about using the average or a minimum or who knows. We could refuse to do it and just return 0. That might be the best. I don't know. All right, let's go look at stream. Okay, here's our stream class we referenced. It's identifiable, so the user interface framework can work with it. It's got a name, it knows its monthly amount, and then we have month numbers. It starts at some month and ends at some month. So far, I've been using that. I'm not sure it's the best way for the long run, but I've been assuming like we'll do a projection for 30 years, which is 360 months. So keeping track of those month numbers. And then in the user interface, I probably will represent that as years plus months in a more human usable. I know what 2030 is. I don't know what, what's month 48 again? And it changes next month when I come in. No. All right. And then all it does is it holds an amount and returns the money. Oh, yeah. So we could be using, this could work. I thought we didn't have this facility yet, but we do check for the date range and add it in. So I should really be calling amount on this. This should probably be treated as private. Okay, but at any rate, when you ask for the money at a given month, a stream knows how much it has that month and it tells you. All right, so here's our application. I only have one of those boxes now. I'm just calling it my finances instead of baseline, but we can add things to the plan, the current plan. So let's make a new stream. It can be salary. I thought I'd turned off the checking. All right, let's give ourselves, let's be generous. Let's give ourselves $10,000 a month. All right, and we'll start in month 3 and end in month 40. You can see that's not as convenient a way to go. All right, and so we added the item in. It's got some information. It's got that defective graph that just takes the amount and starts adding it up. I guess we've done 10 years to 120. That should take the month into account, and the curve should only reflect the time it's growing. All right, but let's add another one. Now this time, let's add a group, and a group is the and node. So maybe we have, I don't know, retirement income. And maybe we'll add an annuity for $100 a month. I can default the months for starting and ending. Okay. And unfortunately, we have to open the disclosure to see that, but that's okay. And let's add another item there. Pension. Who has those anymore? But we'll pretend. All right, and so this is an and node. I don't have any indication of that yet. I'm going to at least have an icon and maybe some coloring or something to set that. But let's add a top level thing for Social Security starting. Let's see. So this is scenarios, the orb tree part, and we'll call it Social Security. And maybe I'm considering Social Security at 67. And I'll get 1,500 starting in month 30. And maybe I'll get Social Security at 70. Maybe I get 2,200. Let's see, starting 3 years later, 30 plus 3, 66. Okay. And again, there's no indication that there's a difference between an and node and an or node, but we will get there on the user interface. But at any rate, what we can see is we're tracking those streams. We will eventually reflect it in the graph, probably first thing next week. And we've at least got the concept of the scenarios, but we don't have interpretation of the scenarios. So really what I'd like to happen is I'd like to see two graphs, and maybe it's on a separate page or something, but I want to see one graph SS67, another one SS70, or maybe it's SS-SS67 or something to let me know what those scenarios are. And I'd expect to see two lines, and maybe I'm starting later, but I get more money. So at some point I cross over, all those possibilities. Okay, well, I think we've got a good start. And like I said, next week we'll fix that graph first thing, since we clearly already have the information we need. And I think the next thing after that is to work out what does it mean to interpret multiple scenarios going on. So this combinatorics notion and how we're going to present that information. So I'm looking forward to it. All right. Thanks for watching. If you want to join us, it's Monday to Thursday, 2 to 4:30 p.m. Eastern Time, or 6 to 8:30 p.m. UTC. You can join in at xp123.com/Twitch. We'll bounce you to my account on Twitch. Or you can go to xp123.com/YouTube and see the old sessions, time delayed a couple weeks and lightly edited. All right. Thanks for watching. Bye-bye.